uniform motion. A teacher would say that uniform motion is when the distance is directly proportional to the time. But let's see what my robot thinks about it. We set our friend Patsy at 50% speed to move for 10 rotations, and at different time periods we took the distance that she traveled. From the data that I collected, I plot a graph of distance versus time, and you may realize that it gives us a straight line. This is due to the object traveling at equal distances for equal amount of time. Therefore, if the object travels 2 meters in 2 seconds, it will travel 4 meters in 4 seconds. Unfortunately, uniform motion is not always faced in a real-world situation. This is due to the gravity, the frictional forces on the object, or even the drag force due to airflow. So that is the reason for non-uniform motion. But unlike uniform motion, this is much harder to predict. But the reason for that is really because of the change in acceleration or deceleration of the object. To prove this, we'll be using our friend Patsy. The robot was set to accelerate at 10% speed per rotation for 10 rotations, and at the different time periods that the robot traveled, the distances were recorded. From the data that was collected, a distance versus time graph was created, and from this graph a curve was obtained, and this is due to the acceleration of the robot. It is non-uniform motion because the distance is not directly proportional to the time, but directly proportional to the time raised by a. And what this really means is that at equal distances you will obtain an equal time. It is a very important and very interesting aspect to think of. It can be found in almost every one of your day-to-day activities, from driving or even walking. It is even used by rocket scientists to calculate the speed at which a rocket will be moving thousands of kilometers above the Earth's crust. Motion, uniform or non-uniform, it still involves time.